Hello and welcome to today's class. For today, we'll be trying to derive the slope equation and deflection equation of a cantilever beam with uniformly varying load, that is UDL, uniformly varying load, using UDL perhaps, using area moment method, right? Using area moment method. In our last class, we tried to use double integration method. So we had two formula there. The slope equation for double integration method was C was equal to WL cube over 24 EI, right? And y was equal to W to the power 4 over 30 EI. These are like the slope equation and deflection equation of a cantilever beam with uniformly varying load using double integration method. But today we'll try to use area moment method, and let's see if our value there will be comparable. The equation there will be comparable, right? So what's the first task? When you're using area moment method, your first task is to draw the diagram. The diagram says a cantilever beam with what? Uniformly varying load. So I'll have a cantilever beam here, something of this nature, a cantilever beam. Let me put it here, a cantilever beam, right? Next up, with uniformly varying load, that is a UDL, something of this nature. I have a UDL, uniformly varying load, something of this nature, right? So when we know that from here to here, from here to here is simply the length, right? Here is the length. So I've successfully draw out my UDL here. So what's my next task? This is a cantilever here with varying load. This is the entire length. What's my next task? My next task is to draw the deflection of this man here. Deflection simply means when a UDL is higher, the weight of the UDL is higher than the beam, than the cantilever beam, it will deflect, right? So let's draw a deflection of this man here. So the deflection of this will become something of this nature. Let me take this up a little bit. Let me call here the length. So the deflection will be something of this nature. This is like deflection here, right? So the deflection, something of this nature. Extend it this way and take this one down here. All right. This is like the deflection for this beam here. So I'll pick a point here. I'll call that point G. That's my center of gravity. From here down here is given to be what? 4 over 5 of the length. The entire height here is given to be WL squared over 6 EI. WL squared over 6 EI. So your task here is just to master the diagram. If you can master the diagram, you are good to go, right? So draw out your cantilever beam with varying load and master this, right? Center of gravity for this man here is 4 over 5L. The height is WL squared over 6 EI. So let's now try to start getting the slope equation before deflection equation. So calculating for slope equation, so for my slope equation, we said slope equation when it comes to area moment method becomes what then? Becomes A, right? For double integration method, it is C. For area moment method, it is what? A. It is A being equal to 1 over 4 times breadth times height. When we did when we derive for cantilever beam with point load at free end using area method, our area was 1 over 2. When we use cantilever beam with uniformly distributed load, our area was 1 over 3. Now this is varying load because what's 1 over 4. Master that stuff, please. It's very, very important. So it means that my area, or perhaps my slope equation, which is A, is equal to 1 over 4 times the breadth. What's my breadth? Entire length here is my breadth, that's L, times the height. What's my height? From here to here is what? WL squared over 6EI, right? I'm here. So let's do arithmetic here. From here, I'll have that my slope equation, which is A, is equal to L times L is L cube. Sorry, L times L squared is L cube. So pick out your W first. WL cube over 4 times 6 is 24. Next up, I have EI. This is like my derivation for my slope equation. Compare this with this, right? So they are the same thing. So that's like the tax there. So let's proceed to deriving the deflection equation. We said when I want to derive the deflection, when you want to derive the deflection equation of a cantilever beam or anything using area method, your task there is to multiply your slope by the center of gravity. That's all. So at this point here, calculating for deflection equation, that's y is equal to, we said, to get your slope in deflection equation, multiply your center of gravity by what? By your slope equation here. So I'll have that slope equation A multiplied by center of gravity, which is this one here, G. So it means that from here, it means that y deflection equation is equal to slope is what? What's my slope there? All right, for me, what's my slope there? My slope is WL cube over 24 EI multiplied by center of gravity, that's 4 over 5 of my length. So from here, if I do my necessary job here, 4 here is 1, 424 is 6, right? So my deflection equation y is now equal to W first, L cube times L is S to power 4 all over 6 times 5 is 30. Next up, I have E I. This is like the derivation for my deflection equation here, right? So this is like the tax there. So it's quite simple. Just master the procedure and you're done. So let's now use all this idea and this concept here to solve a particular problem under this one here. So example 1. Example 1 says a cantilever beam of span of 10 meter span is subjected to a uniformly varying load, that is UDL, of 30 kilonewton per millimeter. Find the slope and deflection value using area moment method. Take EI to be equal to 22 times 10 power 5 Newton per millimeter squared. All right, let's get this done. First task in science, your first task, whenever you do that question, is to what? Write out your given parameter. So what are you given? Solution. My first task says that I'm told that a cantilever beam of span 10 meter. Span is the length. So I'm given length, that's L, of what there? Of 10 meter, right? Is subjected to a uniformly varying load of 30 kilonewton per millimeter. So my load there, which is weight, that's W, is given to be 30 kilonewton per millimeter. Next up, find the slope equation. So slope equation equation. That's A. I don't know. Next up, and deflection value, or perhaps deflection equation. So my deflection equation there is unknown. That's Y. Next up, the question says using area moment method. So there's a condition there. If I'm told to use double integration method, it means that I will not use A, I'll use C instead. This Y remain the same thing. But in this case, I'm using what the area moment method. So that A becomes that slope equation becomes A because I'm using area moment method. So take EI. I'm giving the value for EI to be equal to 22 times 10 to the power 5 Newton per millimeter squared. All right, let's get this done, please. Let's get this done. First task here is that let's try to get the slope equation. We said for slope equation, calculating for slope equation, we said for slope equation there, we said A is equal to W to the power 3 over 24 EI. So next task now, before I start putting value here, let's confirm something. My EI is in Newton millimeter squared. My weight is in kilonewton. So convert this 30 kilonewton to 30 to Newton. So it means that from here, I'll simply multiply 30 by 10 to the power 3, because this kilo is 10 to the power 3. So I'll have Newton per what there, millimeter. Change this kilo to value. Kilo is 10 to the power 3. Then attach this one to it, Newton. So I've converted everything here to Newton millimeter. So I'm having Newton millimeter squared. So it's correct this way now. So I can now solve, right? So next task, let's put in value. What's my weight? Weight is what? 30 times 10 to the power 3 as my weight, multiplied by my length. What's my length? 10. All right, okay. Before I put in value for 10, I'm saying millimeter. This is a meter. Convert 10 meter to millimeter. That's what? 100 millimeter, right? Multiply by 1000, right? Meter, sorry, okay, meter to millimeter. Okay, multiply by 1000. That's 10,000 millimeter. Multiply by 1000. You are there, right? So I'm using the value for this one here. That's 1000, 10,000 perhaps. All what there? All to power 3. All over 24 here. Multiplied by what's EI? Of course, what's my value for EI? EI is going to be what? 22 times 10 to the power 5. So let's try to watch out value. Let's try to get value. For my numerator there, I have 10,000 to the power 3 multiplied by 30 times 10 to the power 3. So I have for numerator, I have that slope equation is equal to 3 times 10 to the power 16 all over, let's get for the denominator there. So I'm having 22 times 10 to the power 5 multiplied by 24. I have 52800,000. So I'll divide numerator by denominator 3 times 10 to the power 16 divided by my denominator there. My value there becomes, hang on, coming 3 times 10 to power 6 to power 16 perhaps divided by 52800,000. Okay, I have a longer value. That's 568181818.2. This is slope, right? That becomes what's my sign in there? My sign, okay, radian. Yes, radian. we said our SI unit for this one here is always in what? In radian, right? So let's try to get the deflection value, please. So let's get the deflection value. So this becomes the radian value here, right? So let's try to get um, for deflection equation. All right, from here, let's get deflection equation. That's why y is equal to, or perhaps calculating for deflection equation. So that's y, right? So what's y? Y is equal to this man here, plus WL to power 4 all over what there? 30 EI. Put in value. Y is equal to, check. What's W? That's 30 times 10 to power 3 multiplied by length. What's my length there? That's 10,000 there. So I have 10,000 all to power 4 all over 30 multiplied by EI. Of course, what's EI? That's this one here. That's 22 times 10 to power 5. So if I multiply numerator and denominator together, what will I have? So from here, I'll try to multiply numerator. 30 times 10 to power all right, 30 times 10 to power 3 multiplied by 10,000 to power 4. I have 3 times 10 to power 20 as my numerator value, divided by denominator. 30 times 22 times, sorry, okay, times 10 to power 5 there. I have 6.6 times 10 to power 7. All right, divide numerator by denominator. 3 times 10 to power 20 divided by my value there. So I have my deflection equation y is now equal to 4.5 times 10 to power 12 in what? In millimeter there. So this is like how to solve this question here and how to arrive at this point here. So if you found this class helpful, reach out by liking the video and put a comment, right? And also share the video to your friends and classmates if you found this video helpful. And also try to join a WhatsApp group. I have a WhatsApp group for my channel, so I'll drop the WhatsApp group in the comment section. So try to check the WhatsApp group there and join a WhatsApp group so you'll be notified earlier before entering into our classes, our online classes, right? So thanks for watching and welcome to Excellent Link Academy.